Multiplication combination. Written and illustrated by Neal. Our standard focuses on multiplying a whole number of up to 4 digits by a 1-digit whole number using strategies based on place value and the properties of operations. Illustrate and explain the calculation by using equations, rectangular arrays, and/or area models. Our I can statements for today are as follows. I can multiply a whole number with up to 4 digits by a 1-digit number using place value strategies. I can use properties of operations to help me multiply numbers. I can show and explain my multiplication using equations. I can use area models to help explain how I multiply numbers. Hello guys, now this is weird. What do you mean? Don't you see? We are all the same. This is unreal. Yeah, you are right. Well, that makes me think of something. Oh no, here you go with your silly ideas. Well, let's hear him out. He might actually have something good to say. I was thinking that we could combine together to become an even bigger force to be reckoned with. Now, that might not actually be too bad of an idea, but how can we do that? I think I have the perfect solution. Multiplication. It is the same as repeated addition, which is adding the same number over and over again. Yes, we discussed this in Mr. Owl's class. So it is 3 of us. We all have a value of 2,568. We can multiply 2,568 times 3. There are several ways to do this. Let's use the standard algorithm. We should start in the ones place and multiply 3 times 8. This gives us 24. The 2 tens would go on top of the 6 in the tens place. We would then multiply 3 times 6, which equals 18. But we have a 2 that's on top of the 6, so it will be 20 because 18 plus 2 is 20. The 2 from the tens place will go on top of the 5 in the hundreds place. The 0 comes down here. We will then multiply 3 times 5, which is 15. But we have to add the 2 that's on top of the 5. This will give us 17. The 1 that's in the tens place will go on top of the 2 that's in the thousands place. We will have to, and the 7 comes down here. We will have to multiply 3 times 2, which will give us 6, but we will have to add the 1 that's on top of the 2, which will then give us 7. This will bring the answer to 7,704. This is jogging my memory. I also remember Mr. Owl talking to us about the area model. The area model is a fun and visual way to show what it means to multiply numbers. With this method, we use the values to help us multiply. We would have to break apart 2,568 into expanded form, which would be 2,000 plus 500 plus 60 plus 8. We would multiply each of these by 3 on our visual area model. we will start with 3 times 2,000. Do you remember what Mr. Owl said we can use to multiply numbers such as these? I actually do. He said that we can use our basic facts, which means we can take the zeros away for now to multiply the numbers, then add them back to the answer. You have such good memory. So, 2 times 3 is 6. There are 3 zeros in 2,000, so the answer would be 6,000. Then we would multiply 3 times 500. 3 times 5 is 15. When we add these two zeros, it will give us 1,500 or 1,500. 3 times 6 is 18. When we add the 0, that gives us 180. And then 3 times 8 is 24. There are no zeros to add back. There's no zeros behind the 8. There's no zeros behind the 3. Now do you remember what all of these answers were called? I'm insulted that you think it's a possibility that I don't know. These numbers are called partial products. We're going to have to add them together to find our final product, which, by the way, product is the answer to a multiplication problem. Oh, you're good. You know your stuff. When we add the partial products together, we will get 7,704. So our partial products, again, are 6,000 plus 1,500 plus 180 plus 24, or 6,000 plus 1,500 plus 180 plus 24. We are 3 smart numbers. We hit this out of the park. Yes, when we go back to class, we will have to tell Mr. Owl how good he taught this lesson and how we were able to solve this problem in our real lives. Teachers want to know that they are appreciated. I agree. See y'all in class. The end.